Good morning, student. Today we start our new session with online with the new chapter matrix. Chapter number 3, matrix. First question is, what is matrix? What is a matrix? So in a simple way, we can say that a rectangular arrangement of real numbers or function is called matrix. Now it means it is just representation of a real numbers or a function like this. Supposed to be some numbers given like 4, 3, minus 1, 2, 4, 7. This is a matrix. But in a matrix, there is a way, specific way for representation of that. We write in this way, or we make it like this bracket 4, 3, minus 1, 2, 4, 7. This matrix normally we represent with the capital letters A, B, C, etc. Means this is a matrix supposed to be A. Normally in our book, this way we represent. You can also represent this way, but in our book they've used this symbol. So again I repeat, a matrix is a rectangular. Now in our textbook, only the one word they've added here, ordered rectangular arrangement of a real numbers or a function is called the matrix, which we represent with the capital letters like A, B, C up to so on, and even you can use capital letters. So this is the matrix A, whose elements are whose elements are 4, 3, minus 1, 2, 4, 7. It means this 4, 3, minus 1, 2, 4, 7 are called elements of the matrix A. Either elements of the matrix A or entries of the matrix A. We also identify matrix by its order. You can see this matrix A having 2 rows and the 3 columns. 2 rows means this 4, 3, minus 1 makes the first row of the matrix. That's why we also represent as R1. This 2, 4, 7 are the elements of the second row of the matrix. So the first row of the matrix is what? 4, 3, 1, minus 1. Second row of the matrix are what? 2, 4, 7. Similar way, column. This is your column, first column, second column, and third column. So the element 4 and 2 makes the first column of the matrix, which we represent as a C1. This 3, 4 makes the second column of the matrix, which we represent as a C2. -1, 7 makes the third column of the matrix that we write as a C3. So in short, these are the columns and rows. So we use this number to represent the order of the matrix. Order of the matrix we normally represent as a m by n. This cross we read as a by, m by n or m cross n. This m represents the number of rows and this n represents the number of columns. So in short, this is a matrix. This matrix A is a matrix of 2 by 3. 2 by 3 means what? This matrix A having 2 rows and 3 columns. Is that clear? So that means here you can also check it. How many elements in this matrix A? So say 2 by 3. So the 2 and 2. That is 2 3s are 6. That you can say 6 total elements in the matrix. This is also you can say as 2 by 3. See, this is about the matrix. When you have a more than one matrix, it becomes matrices. You can say as a matrices. It's a pure. We can also see the different kind of a matrix because it's just one kind of representation of the real numbers. Suppose to be we take a matrix B. Matrix B, you can say like a 2, 3, 4, 7, 9, -4. This matrix 4 having 2 rows and 3 columns, so it is a matrix of 2 by 3. Matrix C, we can say 3 minus 8, A4. This matrix is a 1 row and how many columns? 4. So that's why we can say it is a matrix of 1 by 4. These are the different order of the matrix D. You can also say A, B, C, D. This is a matrix of 2 by 2. E. You can also say 4 minus 1, 8, 3, 5, 6, 11, 12, 13. This is a matrix of 3 by 3. See here again, B is a matrix of 2 by 3. And how many elements it contains? So say 2 3s are 6. Here 1 4s are 4. So you can check it the elements. Here 2 2s are 4. Here 3 3s are 9. Suppose F we take another matrix. That 17, 8, 21, 4 and -3. This is a matrix of how many rows? So say 1, 2, 3 and 4. 4 rows and 1 column. So you can also say 4 by 1. Suppose to be given E, F, G. Suppose another matrix 0, 0, 0, 0, 0, 0. This is a matrix of what? 2 by 3. You can check it the how many elements are there. G, H. We can also say some matrix like that. 3, 0, 0, 0 minus 4, 0, 0, 0, 7. This is a matrix of 3 by 3. You can also say a matrix like this. I is a 1, 0, 0, 0, 1, 0, 0, 0, 1. That is again 3 by 3. J. You can say the matrix like this also. 4, 0, 0, 0, 4, 0, 0, 0, 4. This is again another matrix of what? 3 by 3. Now you can check here the number of elements in a particular matrix also. Here 9 elements, 3 3s are 9. Here again 9 elements. I contain 9 elements. H contain again 9 elements. G contain 2 3s are 6 elements. F contain 4 1s are 4 element. D contains 2 2s are 4 elements. E contain 3 by 3 means 3 3s are 9 elements, like this. Now we have to see a different definitions of the matrices. First one, row matrix. Now just identify out of this example which one is a row matrix. Row means which contain only one row. A matrix which contain only one row is called the row matrix. So C is a matrix having only one row. So that matrix is what? Row matrix. I just give you another example. K minus 4. This is also 1 by 1 means what? Row matrix. Again, a row matrix means a matrix which contain only one row is called a row matrix. Now you understand from this column matrix. A matrix which has only one column is called column matrix. So this F is an example of what? Column matrix. Understand? So on the basis of this, can we say this K is row matrix as well as column matrix? So say yes, because this K has one row, like that it has a one column. So you can all say as K is a matrix of a row matrix or otherwise column matrix. Understand? Now another one is a square matrix. Square matrix, now square itself says this square means it has the same edges, means it has the same number of rows and the column. We define in this way a matrix which has the same number of rows and the column is called the square matrix. You can identify here which are the square matrix. So say D is a square matrix, E is a square matrix, 2 by 2, 3 by 3. H is a square matrix, I is a square matrix, J is a square matrix. Even K you can say as a square matrix. So the important thing is K becomes a row matrix as well as square matrix as well as column matrix. Understand? I repeat, row matrix means a matrix which contain only one row. Column matrix which contain only one column. Square matrix which has the same number of rows and a column. See, there is Now, see this example again. This G, you can see G. All the elements of the matrix G is 0. Then in that case, that matrix is called zero matrix. So how you define the zero matrix? So say if all the elements of the matrix is 0, then that matrix is called a zero matrix. Zero matrix we represent with the O. This is a 2 by 3, so O 2 by 3 means O2 by 3 means a 0 matrix with the 2 rows and the 3 columns, which we represent like this: O 0 0 0 0 0 0. If I say O 2 by 1, it means 0 matrix which has a 2 rows and 1 column. So you can say like this: 0 0. Understand? Similar way, you see the square matrix, example number H. This is a diagonal of the square, you know. When you join the opposite vertex of the square, it becomes a diagonal. So this is a diagonal element. So except diagonal element, all the elements of the matrix will be 0. So in that case, that matrix is called diagonal matrix. Diagonal matrix is what that means. So say every entry or every element of the square matrix is 0 except the diagonal matrix. Then that matrix we call as diagonal matrix. See, so H example we also can write like this. I again write, see, this is 3 0 0 0 minus 4 0 0 0 7. This diagonal matrix we also represent as a DIAG 3 minus 4 7. It means not necessary that these elements are not 0. Maybe this may be 0. These are any real number, but the rest of the elements are what? 0. Supposed to be, I just give you another example. M is a matrix which we are given like this: diagonal matrix 2 0. Means this is a diagonal matrix. This is a diagonal matrix of a 2 rows and 2 columns. 2 0 means what? It has only 2. It's a square matrix of 2 by 2. Means you can represent like this: 2 0 0 0, because this diagonal is 2 0. Maybe you're given like this: N is a matrix, diagonal matrix, like that, 3 0 5. This we represent in this way: 3 0 0 0 0 0 0 0 5. Is that understand? See, don't confuse about the diagonal matrix. Diagonal matrix is always a square matrix. It means either 2 by 2 or 3 by 3. See, 4 by 4. Okay, like that we don't have, but at least 2 by 2 in a 3 by 3. The diagonal elements are a real number, but the rest of the elements are 0. That matrix we call as a diagonal matrix. But suppose in that diagonal matrix, see the example number J, you can see that a 4 0 0 given, 0 4 0 and 0 0 4 given. Means the element in a diagonal form, in a diagonal elements, all are equal. That matrix we call as a scalar matrix. Understood? Here again it is a square matrix, but in a diagonal all the elements are identical and rest of the elements of that matrix are 0. Understood? So just keep in mind the difference between square matrix, diagonal matrix and scalar matrix. Now another example I take to I is what? 1 0 0 0 1 0 0 0 1. See the scalar matrix and this matrix. What is the difference? So say in a diagonal, it has a 1 1 1. So when you have a like this matrix, this is a very, very important matrix for us, that is called identity matrix. Or you can say unit matrix. This is the identity matrix of 3 rows and 3 columns. That's why we also represent as a I3. Identity matrix, or you can say I3. Even if it is 2 by 2 matrix given, if it is 2 by 2 given, then we represent I2. I2 means it is a 2 cross 2. Then elements are like this, 1 0 0 1, which has 2 rows and 2 columns, 2 by 2. Understand? This is a very, very important part of our study. Remember, identity matrix, or you can say unit matrix. So these are the different definition of the matrices. So again I repeat, what is the matrix? So you can say a simply ordered arrangement of real numbers. So you can understand this, or we can generalize this in this way also. See, we just assume as a matrix A, which contain m rows and n columns. M rows and n columns means how many rows? So say first row, second row, third row, like this, m row. And how many columns? So say n column means first column, second column, third column, fourth column, up to n column. Now we generalize the thing. So we say just this is a place for which element. So say first row, first column. Also that we write as A11. When you say A11, it means element of first row. Just see this, first row, first column. So this is the element of what? First row, second column. So we can say A12. This is element of first row, third column. So this element we all normally represent like this, A1n, means element of what? First row and column. So like this, we write rest of the elements A21, A22 up to A2n. Like this, A31, A32 up to A3n. Like that. Last one, this is the mth row. So AM1 means m through first column, means it is the element of m through first column. Like this, AM2, AM3, the up to last element should be what? AMN. So this matrix contain m rows and column. So total mn elements are there, which we also write in a short form. Capital A is in a bracket Aij. This Ij suffix number, this I is stand for a row. I is stand for row, and J is stand for what? Number of column. That you remember. Aij of m cross n. This is one easiest type of representation of any matrix, generalized form of the matrix. A is equal to Aij m cross n. So see here, how many rows are there? M. How many columns are there? Those n. I represent the number of rows. So your value of I should be what? more than 1 but smaller than or equal to m. The value of a j should be what? More smaller than n but more than 1. It equal to m, equal I may be m, j may be n but not more than m or n. Is that clear? This is a very, very important thing. Now you understood what is a matrix. It is the one kind of representation of the real numbers. Now the question is what we have to see in this chapter. What we have to see in this chapter. So see, first is equality. If two matrices are equal, what will happen? Addition of a matrix. Number 3, multiplication of a scalar with a matrix. Multiplication of two matrices and adjoint of the matrix and inverse of the matrix. So like these things we have to see in this chapter. Now the first thing will come, equality of the matrices. Stop.